Last year, he presented how to get JTAG over USB at the 33C3. And today, he will tell us how to interrogate the Intel management engine in a similarly ingenious and devious way. Please join me in welcoming Maxime Goriachi to 34C3.
Hello, guys. I'm speaking about Intel debug capabilities at CC conference for the second year in a row. Last time I talked about how a new Intel CPU low-level debug technology called Intel Direct Connect Interface, or DCI, and now I'm going to talk how activates DCI for Intel Management Engine. Sorry. Connect DCI is a private implementation of widely known industry standards for debugging hardware and low-level software from Intel. And addition, I will talk about how it can be used for research and how to use it in practice. Unfortunately, my colleague Mark couldn't come, and I will introduce our research alone. And I think that you some hungry, and I will be quickly. Our management engine research team at Positive Technologies includes following researchers: my colleague Dmitry Sklarov and Mark Yermolov, and myself. Mark Yermolov, it's my colleague. With whom we founded vulnerability in Intel Management Engine. He is a system programmer and reverse engineer. And Dmitry Sklarov, well-known reverse engineer who did research of the ME file system. He recovered Huffman codes for 11 version of ME. And you can find his tool for unpacking ME image and for parsing ME file system on our GitHub pages. And how you can see, our previous talk related to me and our contacts. You can feel free to communicate with us for any question you are interested about our research. How I have just said, I will talk about what is Intel ME, how it's implemented, and how we activated JTAG for ME core vulnerability, which Mark and I found. Then I disclose in details how our technique works and show proving our achievements. How many people in this hall knows what is ME? Oh, cool. But ME overview. The topic of management engine is very popular now. First, it's almost fully undocumented and very powerful. At the same time, for example, it has full access to your platform's hardware, including CPU complex. It has capabilities to intercept all that you're doing on your PC. For example, keyboard. He has access to keyboard, to USB, and of course PCI buses. And it also a root of trust for many Intel security feature like TPM, like DRAM and APT. Intel has chosen the following design for ME 11 version: independent microcontroller, open operation system based on Minix, built-in Java machine, it gets standard before main CPU. It firmware has parts in PCH burned in memory and in SPI flash. Many Intel technologies are implemented with help of management engine. For example, active management technology or PAVP, and we think that HGX too. Another question. How many people in this hall knows what is JTAG? Cool. But some overview of JTAG. JTAG stands for Joint Test Action Group, and you can find its description in IEEE standards, which the details available in the standard itself. There is also the paper available on our blog where we where the design is described in close details. Out often, manufacturers extend standard JTAG by adding their own functions. JTAG in Intel processor is described rather poorly, and some information can be found in documents and patent. You can see our paper on the slide. And starting with Skylake, Intel introduced direct connect interface technology, and you can find the rather description of it in the documents and in our works. The diagrams show two types of connection using a specific device, the so-called Intel SVT closed chassis adapter, or common USB 3 debug cable. I would like to note that the target system in this case doesn't require any software or hardware agent. The drawback of this technology is that it works out of box. Intel Silicon View technology closed chassis adapter provides access to DayFix feature like JTAG and run control through USB 3 ports on silicon on platforms. It works through USB 3 links, but implements a private protocol and makes it possible to manipulate the target system in deep sleep mode. It means that in this mode you have independent lines between independent links between JTAG adapter and PCH. USB 3 hosting DCI is a common USB 3 debug cable which works as a OTG device. That means that a special device appears on the host system, activation and commands are sent to device through the common USB interface. The device itself is integrated into PCH, and it transforms the command into JTAG. If you have JTAG for ME devices, it means you have almost full control of ME. To main question, does Intel provide of any technique for debugging ME on public platforms? And the second, what does software and hardware need for ME debugging? Okay. The answer to the first question, yes. We found a special partition called UTOC, which are located on the special on the SPI flash, where storage ME. This partition has same structure as FPT and another partition of ME. Partition includes entry of available debug capabilities on of these records, means types of unlock red or orange. Please pay attention, it will be important later. And what means DFX? DFX is collective term for next to abbreviation DFT, designed for testability, and DFD, designed for debugging. DFT is set of technique used for manufacturing defects, finding of integrated chips, and standard DFT is generally based on ordinary boundary scan JTAG commands, but Intel extends its DFT in its branded Silicon View technology. DFD joins all internal chip-level logic used to organize hardware-level debugging of core sequences executed by chips. DFX is connected to internal world by a special thing called embedded DFX interface. This bridge connects DFX with external industry interface like USB. There is a special device in Intel platform controller hub called DFX aggregator. Its function is to control access to DFX. And two types. Orange types, it means that vendors may use JTAG debugging for ICH, for example, and UTOG partition for orange unlock must be signed by vendor's key. This key is stored in FPF fuses. And more interesting is red unlock, because this unlock provides full access to PCH internal devices, unlocks JTAG for ME core, and provides unlimited access to memory, to ME memory. Intel Management Engine uses two devices for support hardware debugging: DFX aggregator management's defects functionality, and CCS zeroing register from device called GAN. And only BAP and ROM uses this device. It is CCS zeroing register. We know only about 1 bit. We called it Intel unlock request. And this register means that you asked the platform to do read unlock. More interesting is DFX aggregator register and personality register. Personality register specifies type of unlock, red or orange, and consent used for allowed write to personality register. It means that consent register it means that this bit to allow write data in DFX personality register, and read unlock working in two steps. On the one, the BAP is finding UTOG partition. If partition found, the BAP is checking partition signature and platform ID. Also, BAP checks time because UTOG has time limitation. And after that, if all is okay, BAP parsing an entry in utalk partition called knops. If Intel knop unlock founded and platform is not already unlocked, BAP set CCS errand register and doing reset ME. After that, in ROM, is checking CCS errand register, and if it's set, it to clean this register and switch on consent and personality. It means read unlock. After that, ROM is cleaning ME keys and working. But if you have active, if DCI is active, ME doesn't latch the fix consent register. It means that if you want to switch on JTAG, you don't need to reboot ME if you have DCI connection. And how activate read unlock without Intel keys? On Black Hat Europe, we disclosed bug in BAP module. This function, as you can see, has a vulnerability. When it calls other function reading in BAP CT file, it gives incorrect size of data to read. Instead of local buffer size, the buffer DFS read file function gets the size of the whole file. How we exploited this vulnerability you can find in our presentation from Black Hat. And using the vulnerability, we also have activated JTAG for management engine. And to research ME, internal of ME. Read activation without Intel keys may be doing after 4 simple steps. On the first, activate manufacture mode for target. It needs for DCI and set DCI strap in a flash descriptor. And using the vulnerability to load value 3 to the fix personality register. And after that, you will have ME core, and you can to research internal ME. But unfortunately, you will have one problem because you don't have software for debugging ME. But it is small problem. Next, let's talk about software part of technology stack. It's presented by DAL Intel DFX abstraction layer package. Its LH library exposes all power of DFX software model. As we found, DAL has large history, supports various platform and CPU architecture, designed to work with different debug ports and hardware. We know that DAL is a core of all instruments that Intel uses for testing and debugging of its hardware and firmware components. So it's provided with Intel System Studio, for example, and can be downloaded without any NDA. And DAL is almost written in C# and has same structure. On the top, DAL has interface, console interface and GUI interface, and library layer, and driver, transport, and the fix on target. We found a patient from Intel in public description correlation of DFX, EXI, and internal interfaces. You can see our previous work to details about how internal structure of DAL works. DAL's architecture is based on node notion. There are two types of nodes, physical and logical. Physical nodes represents three of hardware components organized from probe unit and including the following levels: GTEC, E2C bus, and another. Logical nodes represents certain functionality that can be used to perform debugging stuff. And many problems that public version of DAL doesn't include configuration for ME core. However, that didn't stop us, and we found the solution. How I said, DAL has some configuration, and as we investigated during reverse engineering of the DAL library, its configuration is included in encrypted XML files. DAL uses IS cipher and key derivation function PBKDF2 with fixed key and salt. The first of lines of poem it is salt, and ATP is a key. The simple program allows decrypt all device configuration of DAL. Thank you. Maybe another poems to decrypt, for example, microcode of CPU. I don't know. However, there is no configuration of ME devices. We found that ME core is LMT2 devices, and the configuration of this device can be found in decrypted XML files. Therefore, anybody can write configuration for ME. For example, on the slide you can see internal structure of LP series of PCH. It is U series of CPU, and SL tab divided on 4 parts, and on top connected parts SME and ME core. And how to do custom configuration? 4 first steps. On the first, decrypt XML files. The second, add the following lines to top ASPT XML. And use DAL environment for ME debugging. And it will make your computer personal again. Some demo. One moment. Okay. It is trial version of System Studio, and we decrypt files with configuration of DAL. and to add some lines. The top is for H series of PCH, and the bottom for LP series. It is ME core. It is linked between ME core and CLTAP. We hold their execution. We loaded we are loading some library, our library. We set up reset breaks. It needs to stop on reset vector in ME. How you can see GDT table and current instruction and register value, LDT value, and we are doing reset ME. And stepping instruction into ME. The initialize of segments and new GDT value. Okay. And okay, and demo from Black Hat. It is our stand. It is host platform. Retrieve halted. We init settings for ME core. Oh, sorry. It is not ME. Reset vector, how you can see. In Hatcher interface, it is a special device between which manufacture for links between host CPU and ME. And now we read some read-only register for CPU from Hatcher. And set the value of this register from ME. The magic. And my demo is more interesting than my English, sorry. And I have a live demo. Oh. If internet will be good. One moment. It's my machine on the work, and the internet is not good, sorry. Maybe later. Okay. And our achievement, JTAG activation, we do JTAG achievement in respect to the vulnerability. In addition, we activate JTAG for ME. Also, we dumped the ME started code and found the way to extract platform's key used by their flash file system. It means that you can decrypt and integrate your files into ME, and ME doesn't detect it. And our links on our GitHub page, you can find our tools for ME reversing, researching, and our blogs with our article, our reference. And thank you for your attention. Question, please.
So anyone that has a question for Maxime, please line up by one of the microphones. They are 1, 2, 3, 4 on this side of the room and 5, 6, 7, 8 on that side of the room. If you are watching online, we have a signal angel who is monitoring the internet for all of your interesting questions, and they will be asked. So already here at microphone number 1.
Okay, so you mentioned that you dumped the ROM. And previously, there were some firmwares with ROM bypass available. Did you compare the dumped ROM against ROM bypass?
Yeah.
And is it the same?
No.
No?
We found there's some difference, but it relates with that ME bypass code starts into protected mode, but real ROM starts into real mode.
Okay, so otherwise it's functionally almost the same.
We found some difference in cryptography, but I think it is not important.
So if you are leaving, please be quiet. So the talk is still going on. We're still having questions and answers, and please be considerate of the people asking questions. Thank you. The next one from microphone number 5.
Yeah, so you set the personality register to red, and then you reset the ME, and it will break at the reset. Is that register persistent over reboots, or you have to do the exploit and set it every time?
Yeah, you need to do it every time. This only CC zeroing persists between resets.
Signal Angel, is there a question from the internet?
Yes, they'd like to know where to find the internal USB port on the main board.
Sorry, please repeat the question.
The question is where to find the internal USB port on the main board for the JTAG access.
How I know, all USB ports now has access to DFX functionality. You don't need to find each ports on your system. If you have a platform with Skylake, you always has this functionality on your USB ports. Oh, of course, if these ports link it directly to PCH. If it is ports connected via some another controller, you probably don't have DCI on this port.
Microphone number 2.
Does your work means you can extract any key from ME, for example, key for SGX remote attestation?
I don't know. We are starting this research how ME relates with SGX, and I don't know how key in ME extract, derive and load it and relate with SGX. I don't know, sorry.
Microphone number 1.
Did you receive any messages, any recognition about this from Intel?
You mean that did we share this information with Intel?
No. Did they react to? Did they react in any way to that?
After our vulnerability, they said, "Okay."
Okay, no, so nothing much except for patches.
Yeah.
Okay, thank you.
Signal Angel, is there another question from the internet?
Yeah, how can you disable the JTAG access? Is just disabling the ME enough, or what do you have to do?
Sorry, you mean how Intel disabled DCI functionality for me? And
how can you fix it now? How could Intel fix it, or how can you secure your own system?
It is not. It is a feature. It is not bug. Sorry. You don't have any chance to switch on JTAG for ME if you don't have UTOC or you don't have vulnerability. And JTAG for ME switch on only inter BOP module. In BOP module, if we have vulnerability in other module, for example, in AMT, we mustn't do it. And if you have it, it's feature, it is not bug. You can switch off DCI in Flash descriptor and to fix DCI problem which we found in last year, and it will be okay.
Microphone number 4 in the back.
I believe one of your previous slides mentioned that they incorporated a Java virtual machine. Why in God's earth did they do that?
How I know this, it is dull and it has some relative with SGX when I know. I don't know details.
So microphone number 5.
On the last slide you mentioned the extraction of platform keys. A simple question, are they enough to sign a firmware update which you would modify so that ME would accept it?
No.
And
Sorry. Please repeat.
Okay, so let me rephrase.
I understand. Okay. The firmware signed by Intel public key. I don't have private key of Intel, and this key is not built into me. It is only platform key. This key for symmetric encryption files and signed files on the file system. If you have this key, you can only modify ME file system, but unfortunately the execution module stored in other places.
Okay, I get it. So no easy path for castrating system from ME yet.
Yeah.
Thank you.
Thank you.
Signal Angel?
Can you have only free software running on the ME?
Sorry, please repeat question slowly.
Can you have only free software running on the ME by modifying the flash contents?
I don't understand, sorry. You mean that how we can modify the file systems or not?
Yeah, replace the ME firmware by free code.
No, unfortunately, because we mustn't to change the chain between ROM and BAP module, and we mustn't to change kernel of ME and BAP module. I don't know how use it functionality for change ME to open source solution. But of course you can do special device with JTAG functionality which to replace after reboot all ME from reset vector and execute it, but it is impossible, I think.
Microphone number 2.
Are you aware of anywhere where the Minix image has been leaked somewhere where perhaps it could be downloaded and analyzed?
Unfortunately, the kernel of ME only based on Minix, and the Intel guys almost all to rewrite almost all kernel and only reverse engineering. And maybe you can get information from Intel after signing NDA. I don't know.
Microphone number 8.
Do you think it will ever be possible to add your own public keys, or are the Intel public keys for signing the firmware stored in a ROM only?
Oh, sorry. You mean?
Well, could you add your own public keys for signing firmware with, or is that not possible because the ME checks the public key that is of?
ME checks. ME checks only hash of public key, and we know that ROM has that ME made to load version of ME which signed on 2 keys. We saw only 1 keys from boss, and ROM checked that checks the SHA from public key exist in white list. ROM has hard-coded 8 hashes of keys and some list for some white list of these hashes. And if you keys in this list, you can run your ME firmware.
Okay, but that list of hashes is in ROM.
Yeah, yeah.
Okay, thank you.
Signal Angel?
What is your general impression of the security of ME? How vulnerable is it to attacks?
Sorry. You mean how vulnerable? You mean how vulnerability to help us do it? Sorry, I didn't.
No, how vulnerable is it to other attacks?
On other model, yeah?
Sorry, on the what?
In other module.
So I think the question is, in general, how good is the security of the Intel ME?
So, sorry, echo.
In general, how good is the security of the Intel ME?
Oh, I think that, of course, yes, because the independent researcher can use it for dynamic analysis of ME codes. It's cool, I think.
Microphone number 7.
Do you have plans to research some specific parts of the Intel ME in the future?
Yeah, of course. Intel will publish ME11 version, and I know that they changed half-mon tables, for example, and the next round of this game will start it.
Is there another question at microphone 7?
So, if I understood you correctly, just to make sure, this means that if you have a CPU of this Skylake architecture and a USB 3 port, you can always get low-level access to the ME.
Exactly.
So if I were to own such a chip, I would want that patched. What's the usual path? Does that come in a Windows patch or a BIOS update, or what is it?
You have some ways to use it. If you have SPI programmer, you can rewrite Flash. You mean how you can exploit it? Yeah.
No. How will Intel distribute a patch for this vulnerability?
Oh, unfortunately, because downgrade always possible. Intel patched only error in bub function, but researcher or attacker can always to downgrade version or to early ME and exploited it without any problem via SPI controller or SPI programmer and maybe another way.
Yeah. Okay.
Thank you.
Microphone number 1.
In the demo video, we saw the connection between the two machines with this blue box.
Yeah.
But I think there's another way to connect them with just a USB cable. Is there anything you can do with the blue box that you can't do without it?
Yeah, we checked it, we use only USB 3 debug cable, but it is not possible for us because we need to recover the state of WAP for loading ME. I do it, but I don't like that because I need to stop execution for my research. It's easy for me, and because we are using Blue Box.
Thank you. Signal Angel.
Do you plan to publish a mask ROM dump in the future?
Yeah, we will plan to do it, yeah.
Signal Angel again.
Just give me a moment.
I don't know, maybe when I come back to Moscow.
Any other burning questions? Please come up to one of the numbered microphones. Then with that, let's give Maxime a great warm welcome.
Thank you very much for your attention.
Thank you so much, Maxime.